Recording
Awesome.
is going. Now go forward, please.
Awesome. Well, thank you all for being here today. I have a really exciting topic, something that I'm fairly passionate about. It's pretty new in Fabric, so it's really, really exciting. I think it's going to change the game in terms of how we look at data, not only as a data analyst, but from the business and organizational side as well. So today's topic is enhancing data literacy with Microsoft Fabric Ontology. Before going into it, just want to give a little background about myself. I am a Microsoft MVP, a Fabric super user, and also a user group lead for the Orange County Fabric Microsoft user group as well. I specialize in data engineering and analytics on the Microsoft data platform, so doing the full end-to-end data lifecycle from ETL all the way to report development as well. And currently in my day job, I am a consultant at RSM US LLP, so I do work there as a consultant, helping organizations streamline their workflows and their data into a single unified platform. Quick agenda today before we dive deeper into what ontology is and how it can really transform the data landscape. First, I want to go through how do we connect data to the business? So how are we connecting data to the business in our modern day data landscape and data applications? Then I want to talk a little bit about what is Fabric IQ, which is the overarching workload in Microsoft Fabric that hosts ontology. Then diving deeper into ontology, a little bit about what ontology is, the core concepts of ontology, and at the end to close out, why does ontology matter in our data landscape? So first, when it comes to connecting data to the business, I want to take a look of the goal of the modern data platform, the goal of the modern data stack. For many, a lot of organizations are trying to achieve is a single unified data platform where all of your data from your multiple places of data sources, whether it be files, databases, applications, ERP, CRMs, bringing all your data into one unified platform and using ETL tools such as notebooks, data flows, SQL jobs, or even pipelines to move that data into an enterprise data warehouse for consumption and for downstream applications. This is the goal that a lot of data platforms survive, not Microsoft Fabric alone, but even other cloud providers as well. And really the goal of this is to provide a governed, scalable solution for reporting, analytics, and data consumption. But even though this is the modern data architecture and the modern data goal, there's still a gap. Data is often organized by functional domains. So as we build our enterprise data warehouses or build our data layer for consumption, oftentimes what we'll see is that as we're modeling our data, whether using dimensional modeling, a lot of times we model our data towards functional areas. This could include a sales model, for example. Maybe you're modeling data for a purchasing department or procurement department. You also might be modeling data for finance, let's say whether it be your general ledger, your AP, your AR. And oftentimes, all these models reflect structures in the system. So they represent functional areas rather than the whole entire workflow. And a common challenge with this is that while these are really great for servicing data for consumption for end users in those specific departments, oftentimes these are still silos. I know a lot of times when we're moving data out from our source systems into a unified data platform, the goal is to de-silo and decouple that data, make that data interoperate with each other and communicate with each other effectively. However, as we're modeling this data, a lot of times there still will be domain specific silos. And oftentimes what that bridges between those domain specific silos, especially as we model data, is often technical expertise that is specific to the business. So a lot of times you'll have your data layer, you'll have your business, and in between you'll have a business analyst, a data analyst, a data engineer, data scientist, someone who understands the business and the data side. And a lot of times what that gap means is that a lot of times the business meaning lives in people rather than the data. So a lot of times you do have a bottleneck in between your data and your business, which is going to be that one person who understands that functional end-to-end workflow. And what I like to call this is really the semantic gap. So what the semantic gap is oftentimes as we're developing these functionally independent data models or semantic models, a lot of times reports are built on top of it, and they're built to really answer domain-specific questions. And oftentimes, if you want to start reaching into other domains or functional areas, you will need to create either custom joins, custom logic to make those functional areas talk to each other. I know I've had plenty of times where I've tried to merge data from the sales all the way to the invoicing to the purchasing. And oftentimes it is a mess because there are many layers and how data is distributed across those functional areas is very different. Another semantic gap is that AI tools often rely on table names and column metadata. So when you're using tools such as AI only knows what it's given, and what it can see right now is your tables, your data structure, your schemas, and that's the extent of the knowledge it has. And that really creates the bottleneck. And what the bottleneck is going to be that institutional knowledge. That's going to be a gap for not only AI, as AI operates on top of your data, but it's also going to be a gap for a lot of users in your organization, especially when your organization is trying to scale. Let's say you're bringing in new members into your organization. A lot of times that those new members do take some time to skill up and get up to speed, just because there is a lot of components of the business and the data as well that may be challenging to understand and get a full grasp of that end-to-end workflow. So how can we solve that? So what is Fabric IQ? So Fabric IQ is Microsoft's solution to this problem. How can we solve that semantic layer gap and have all of our domains, our cross-functional domains, start working together in one interoperable solution set? So Fabric IQ is really the core of a unified data language. It is a new workload in Microsoft Fabric, and it was recently announced at Microsoft Ignite, which I believe was last November. So very, very recent. It is currently in preview. However, it is available to the public, so it's public preview. And as a note, as it is in preview, I would recommend that while you do test this out, don't develop too much, as things are still subject to change, and there may be some flaws or some rooms for improvement with the current solution set. And the goal of Fabric IQ is to really unify the data that sits in your environment right now. So all your data is sitting in OneLake in Fabric. Start unifying that data, not at the data layer, but on the context layer. So giving it a better understanding of your business and how your business operates and how data flows throughout your business. And once it's applied to your data, the goal is to serve this data with that business context to downstream applications so that downstream applications can have a better understanding of your organization, your goals, and how the data is used and how it can use data to transform that into information. So what are the Fabric IQ capabilities? So Fabric IQ currently consists of 5 core capabilities. Some of these core capabilities are actually already in Microsoft Fabric, so you can already use them. They are production ready. And there are some that are a little newer. So Ontology is going to be one of those core capabilities in Fabric and the one we're talking about today. This one is in preview. Likewise, same with Graph in Microsoft Fabric. Graph in Microsoft Fabric is a tool that allows you to see the relationships between your data and how data relates with one another. That's also a preview feature. And then lastly, those last two in preview are going to be those Fabric data agents as well as the operations agent. So those are going to be preview features in Microsoft Fabric as well. And those are going to be catered towards your advanced analytics and AI workflows. So using generative AI to give you insight about your data, which is going to be done by those Fabric data agents. And the operations agents are really going to take that to the next level. So how do we use AI to not only give you generative insights about your data using natural language, but how can it actually take your workflows to the next level? So that's automating actions and taking actions based on the data. And the last part of Fabric IQ is going to be your Power BI semantic models. These are the same Power BI semantic models we know and love. It's now a part of that Fabric IQ workload. And all of these capabilities together really aim to build a new semantic layer that's on top of your existing data and that lives in OneLake. So these all operate together to paint the whole picture of, hey, this is my business, this is my organization, and this is how data moves from one place to another and how it really talks to each other and how the business uses that data. So now that I've given a little background about what is Fabric IQ, I want to dive into ontology. So what is ontology within Microsoft Fabric? So ontology is a structured way to define the organization's business language. It allows us to create a shared meaning layer across systems, domains, data, and all of our data sources in Microsoft Fabric. And what this allows us to do is that as we're defining how our business operates with the data, it allows that business definition to go beyond just tables, columns, and schemas, and allows us to actually create these governed business concepts that as data is coming into our environment, the way Fabric is set up already, it understands how the data operates with one another. It's governed, it has rules and there's constraints around it, so that Fabric can better understand how does our data work together and provide insights and recommendations to really take our business to the next level. So it defines business objects, their attributes, and how they relate to one another. And this really allows for consistent interpretation of data across multiple teams and really takes AI to the next level, allowing it to get better reasoning, better automation, and better, more informed decision making from an AI level. So I know I said a lot about ontology, and it might get a little confusing. I know when I first read about ontology, it was really, really confusing. There is a lot of different concepts. So let's actually take a look at a real world example. So in this real world example, if you know me, I love food, I love to eat, and I love burgers. So I decided to make an example out of my favorite burger chain. And as you know, I'm from Southern California. So my favorite burger chain is Whataburger. So let's say we're going to Whataburger. If we look at the whole picture of the business, and this is not all aspects of the business, but this is a more constrained component of it. There's a lot of different parts of the business. We have at the bottom left, we have a customer. The customer, for example, can go to the restaurant and order food. So you see a relationship between the customer and the restaurant. You also see a relationship between the customer and the food item. And then you also see the chef. The chef works at the restaurant, so you see a line that's drawn between the chef and the restaurant. That's another relationship. And the chef also cooks the food, which is sold by the restaurant. So as you see how we're building out this network between relationships between all of these items, you see all these lines, all these relationships being drawn that normally are really complex to apply to a data warehouse level. Traditionally in data warehouse levels, everything's going to be one to many, many to one. We're really aiming for that star schema, that dimensionally modeled data that's really efficient for reporting. But it doesn't allow us to do to this context where we can actually combine different domains and different concepts. So with customers ordering foods at the restaurant, that's really going to be our sales, for example. However, there's also that procurement piece. So how does the restaurant get inventories for their chefs to start cooking food? So we look at the top, we have restaurants. They order ingredients from, let's say, a farm, for example, that's delivered from delivery truck. The delivery truck carries the ingredients, and we look at that top right section from the farm, delivers it to the restaurants. So we have all these interwoven, interconnected relationships within this model, and you actually start seeing a web of relationships and how they relate to one another. And ontology allows us to describe this and define it in Fabric, so that as Fabric gets data from our multiple source system, it gets a better understanding of how does this data relate to one another and what's the end goal of our data. So for example, right now in our siloed, our domain specific data models, you might have a sales model, you might have a purchase model, but when AI looks at this, it doesn't really know how it ties together, or even when humans look at it. Yes, I understand the goal is to sell more burgers, for example. The business goal is always to sell more, so sell more burgers. But how about the purchasing goals? How does the purchasing goals tie in with the sales goal? Yes, when we're purchasing, we're looking for the best quality product, for example, from our vendors. We're also looking for the best cost from our vendors from a supply chain perspective. And we're also looking at lead times, how long does it take for that product to get into our stores? And all of this is actually a larger picture that comes together in one big piece from a business level. But at the data level, it's always been a challenge of how do we tie that back together? So that's at a high level what ontology really is and how ontology is meant to tie back all of our relationships to one another. So what are the core concepts of Fabric Ontology? At its core, Fabric Ontology is defined primarily by its entities. So entities are a standardized business concept, and it establishes shared definitions, identifiers, and attributes about those concepts as well. And this ensures consistent meaning across systems and teams as well. So if we think of entities and we think about our traditional data warehouse models, our star schemas, an entity is going to be really similar to a dimension. So it's going to be an attribute you can slice and dice upon, and it's going to be one of those things that are core attributes of your transactions. And then we have entity instances. Entity instances are just instances of your entity. So they represent a single occurrence of an entity type. And it's created from bound data. And within the ontology, it can actually track the source as well as the validity of that entity as well. So you can define rules for entities. For example, let's say my customer always has to have a name. They always have to have an address, for example, something to identify them by. And as you define these entities, it's really going to help you create consistent relationships for AI-ready business objects. And as I'm starting to talk about entities more and start going down these core concepts, what you're going to notice is that ontology looks a lot like a semantic model, where you have your dimensions, you have your facts, you have your relationships, you have your cardinalities. It's going to look very, very similar. However, where ontology differs is that ontology is meant to take your semantic model to the next level. So how I like to look at it is the semantic model is going to be your core baseline, and ontology is going to elevate that. Where your semantic model only looks at model data warehouse data, ontology can actually take that to the next level by connecting to other data sources as well. So let's think about our star schema, for example, in our Power BI semantic model. We have dimensions such as customer located here in this image, as well as let's say our items, so the food, for example. This might come in our model data warehouse data, but maybe we're also getting real-time data as well. We have real-time online ordering or real-time store ordering from all of our franchisees, for example. The nice thing about ontology is that not only can you connect your data warehouse, your data lakehouse to it, you can actually also connect real-time data or other data sources to it as well. So as you're getting these multiple streams of data in multiple business processes, you can define this all in ontology, and ontology will have an idea of how does this operate together, and it allows you to paint that whole picture of your business and query a lot more efficiently without the need for complex or custom joins. So the nice thing about ontology as well is that it's a full no-code experience. So once you have all of your data elements defined, ontology is just all about using this interface in Fabric, this GUI that you can define your relationships, define your entities as well. And the next core concept of ontology is going to be your properties. So as we're defining entities, each entity is actually going to have a property. And a property is a defined attribute of that entity. So if you think about it, attributes of that entity, they have specific data types and a consistent structure, and they link directly to your data source. So we think about how we have dimensions in a semantic model. A dimension, let's say our dimension is going to be our item dimension. It might have a name, a category. In this case, for food, we've identified calories as a property as well. So a property is going to be a property and entity are going to look very similar to your dimension in your semantic model. So your properties are going to be attributes of those dimensions or attributes of those entities. And you can link these directly to your data sources through binding. So as you're bringing in data for items, for example, if you have properties coming through real-time data from lake houses, you can go ahead and connect those directly to your sources, and they'll go ahead and collapse all those entities into one centralized location for business ingestion. It also supports semantic tagging, so you can have identifiers, metadata, classifications, all tagged to your entities that allow for better data quality, data governance, and rules as your data is coming in. Next is going to be your relationships. So the relationships in ontology are going to be very similar to your relationships in your semantic model. So they are a defined directional connection between entities. They specify how concepts relate across the business and include attributes such as distance, confidence, effective date. So where relationships in ontology really differ from relationships in semantic model is that similar to that graph we mentioned earlier, you can have weak relationships or strong relationships, depending on how far away each entity is from the process. For example, you might have a customer that orders food from a restaurant. The customer and the food relationship is very close because the customer directly orders that food. However, if we look at the overall business process, the customer orders food that was procured by a farm from the ingredient side. The customer is related to the farm to some extent, but that's going to be a really weak relationship. And how that relationship is defined is going to be through that ontology graph we showed earlier. So that Fabric has a better understanding of, hey, what are the nodes, what are the entities that come between these relationships to really define the bigger picture in terms of the business context. And with relationships, it also enforces cardinality rules as well. So similar to how you have one to many to many, or many to one in your semantic model relationships, you're going to have the exact same cardinalities inside the ontology, except now with more options and more expansion and extensibility in terms of how your relationships look in the bigger picture. And what this really allows for is it makes business context explicit as well as reusable across your domains and source systems. The next concept that's a core part of Fabric Ontology is data binding. So this is where it really takes your semantic model to the next level. So right now, I mentioned earlier, you have your semantic model. That's going to be the core of your ontology, right? It's going to be that baseline you can use that already defines a lot of the relationships between your data. But now you can actually connect your ontology to other data elements, other data models, and other data sources within Fabric. So with ontology, as long as your data is in Fabric, you can pretty much connect it to the ontology itself. And it defines how your data sources align to entities and how they relate to each entity as well. So within your ontology, you can add data sources, whether it be from lakehouses, real-time data, or other data sources as well, and define, hey, where does this come in the picture? So let's say we have sensor data to see, hey, we're trying to manage let's say we have a drive-through, for example, at our restaurant. We want to make sure we're managing operations and see how this correlates. See how this correlates in the bigger picture. We can have sensor data coming in to see how long does it take for us to procure food for the customer, as well as we can tie that data back to our inventory, for example, on, hey, how are we doing on inventory? Do we need to order more inventory? And connecting all these data sources to paint a larger picture. And that allows for AI to do, not only AI, but humans to get a better understanding of the business, the data, and how it interacts with each other. And it also allows you to standardize data types across multiple systems. So as you're getting data sources from multiple systems, the ontology allows you to standardize all of your data into one location. The data types will be the same as well. You can enforce constraints and rules to make sure that data is coming in as intended and that data talks to each other a little more efficiently as well. And it also does support schema evolution. So with your traditional semantic model, someone might add a column to a table, add a column, and that might all of a sudden break your semantic model. You might have a new column in your dimension, a new column in your fact, and all of a sudden your semantic model goes down. With ontology, as schemas evolve, as schemas grow, those relationships maintain the same. So those schemas will grow with the ontology, and it will give it more knowledge to actually build a better idea of what your relationships within your entities look like, and how that overall picture looks like as well. Ontology also captures data lineage, so it can actually show you where your data originated. So where did that initial point of data come from, and how does it move throughout your business as your organization uses that point of data as well? And this really allows for the data to become from raw records into governed, trusted business objects. The next core concept of ontology is actually going to be that ontology graph. So that ontology graph is going to be really similar to that image I showed earlier of that example of the ontology, that network. You don't actually have to build it yourself within Fabric. As you're building it, it's actually going to generate this graph for you, like you see on the right here. And it's going to be a queryable network that's actually going to show you how your entities relate to one another. So you define the relationships once, and then you can see how instances travel across your entities and throughout your business. So and as you're looking at the ontology graph displays your entities as nodes. So you're going to see those as little circles. And they're going to show those relationships, or what they call connections, as edges. So edges are going to be those little dots on the edges of your circles and your nodes. That's going to show how those relate to one another as well. And the really cool thing about ontology is that because you've already defined the business logic once, connections can start being logically inferred. So they don't have to be explicitly defined. As ontology gets a better understanding of your business processes, it can automatically infer your logic of your business and start making inferences and recommendations based on your organizational goals. It also retains lineage. So as data is moving, similar to what I mentioned earlier, it does retain lineage of how data moves throughout the ontology, as well as where it's sourced from. And it really allows you to explore your business in a more visual way that shows you, hey, let's say this, like in the concept of our restaurant earlier, let's say, okay, we had this ingredient from the farm here. How does that ingredient move from the farm to our customer who's actually ingesting that and consuming that? Gonna take a brief pause. I know I threw a lot of information out right away. Any questions from the group in terms of what we covered so far? Gonna use this pause as a water break real quick as well.
Think you're good.
Awesome. And if this is confusing, I completely understand. It took me a couple hours of looking at this graph to really understand what ontology is. I think ontology is in itself a fascinating concept that's a little challenging to understand just because you're attempting to relate a lot of areas of the business that don't normally relate easily in a data warehouse, but they do from a business context. So all these concepts combined can make a really, really, really impactful way of how you can actually transform the way your business operates. And next you have ontology querying. So once you have your ontology defined, your ontology built, that's where you can actually take it to the next level. So how you take ontology to the next level is going to be really incorporating AI into your ontology. Oftentimes, a common challenge of AI, especially Copilot, for example, in Fabric, is that it doesn't understand the context of your business. Recently, I would say in the last couple months, Microsoft did release a few tools that do help and do assist with this. They released Prep Your Data for AI. Not sure if anyone's tried that in the semantic model, but those are tools within the semantic model that can start prepping your data for AI. And what that allows you to do is really define rules for Copilot and in terms of how it interacts with your data. You can set up visuals that are verified answers for AI. So when users question the data or query the data with Copilot, if it's a question that's commonly asked, it can return an answer that's been human verified. And from other features within Prep Data for AI, you also have AI schemas, so you can define, okay, as users are querying my data, make sure you maintain focus on this subset of data as well as instructions. So you can start adding business context in free text format so that semantic models can get a better understanding of what your data is, and AI can go ahead and take that knowledge and apply it further. However, there was still that gap. That knowledge did exist primarily within each semantic model, so it was still siloed out by functional area. Ontology querying takes it to the next level because in Fabric, we have data agents. For those who are unfamiliar with data agents takes Copilot to the next level. So data agents is going to be your pre-built Copilot or data agent within Microsoft Fabric. And it allows you to connect to multiple data sources as well. So in this case, you might connect it to, let's say, a few semantic models. Let's say we have a data agent. I'm going to connect it to my sales semantic model. I'm also going to connect it to my purchasing semantic model. So similar to that example we mentioned earlier. While these two functional areas don't necessarily talk to each other, the data agent can still query that data. However, until recently, the outputs from those were a little bit vague, and sometimes the agent would have to make a lot of inferences on your data as well, as it doesn't know how those semantic models relate to one another, as well as what is the relationship between them and how does it affect the business. Oftentimes, when the data agents interact with semantic models, they use it as a data source, they use it as a knowledge base. But at the end of the day, it only knows what it knows. The only context it has is what's in the model, what's in the metadata, and what's in the semantics. With ontology, you can actually use the ontology as the data source itself. So within your ontology, let's say you have multiple entities, like your customers, your items, your stores, and you've connected them to not only your sales semantic model, you've connected them to your inventory semantic model, your purchasing semantic model. And ontology has that understanding already built in because you've defined that of, hey, here's how my data relates to another, here's how these functional areas relate to another. And now as you query that data agent backed by ontology, the data agent's going to have a better understanding of how that data relates to another, and it can start driving more agentic workflows in terms of, hey, when I'm asking data, I have better trust in the data because the agent understands exactly how data moves throughout my organization. And it ensures that as the agent is reaching to different functional areas to pull data together, it's following those predefined rules. So those predefined filters, those governed rules, constraints are all being applied as AI agents are working with your data. And ontology querying also allows you to take it to the next level in terms of taking your data agents and moving it into a more agentic workflow in terms of automation. So in addition to data agents, now we have operational agents in Fabric. And that actually allows you to orchestrate entire workflows based on the data. So for example, let's say we go ahead and let's go back to that drive-through example for example. Let's say we're tracking sensor data, we're tracking the time for the chef to start cooking the food. Let's say we notice that our drive-through is backing up and our KPIs are down. We can, from that, the ontology can actually trigger a workflow. Let's say you have a Power Automate flow that says, okay, we can send a signal to our employees to tell the driver to, let's say, park outside. And it's a very common example. Sometimes they'll tell you, the driver will say, hey, can you go ahead and park out there in that spot right there, and we'll go ahead and bring out your food for you. So that's one example of a workflow that can be automated entirely. You can go ahead and send alerts, send notifications, and from a larger business or enterprise context, there's so many workflows that are driven by data that now that we have this ontology, now that we have these operational agents in Fabric, as the data is getting monitored, as it's getting tracked, these actions can be orchestrated entirely automatically. And there is still a human in the loop. So it's not something that, hey, AI is taking our jobs, AI is going to do everything A to Z. The nice thing about ontology is that you can embed this into teams as well. So as operational agents are looking at the data, looking at how it moves, looking at how it flows, before it actually executes an action, it can send a Teams notification saying, hey, we've noticed this in the data. We know the goal of we know the goal of your organization, the goal of your business, and we are recommending you trigger this workflow based on our understanding of your organization from the ontology and using our AI generated insights. And from Teams, you can say, okay, yes, trigger this workflow or no. So there is still a human in the loop as it's going through this, but this really allows for better understanding of your data and really letting the AI and these agents get a better understanding of data so they can really drive these workflows rather than relying on that crutch, which is that bottleneck of having someone that understands the data as well as the business. So why does this really matter at a high level? So the impact of ontology is it really moves the data, it helps you move from tables to business meaning by shifting focus from not just the technical schemas, but to the business itself. A common saying that Microsoft uses is that let's say you're in the C-suite, you're the executive, you don't want to be the chief integration officer, you want to be like the chief information officer. That's a common saying that we hear Microsoft say a lot, and really how they really market Microsoft Fabric as a tool. But this takes it to the next level. So not only do you not only have to worry about integrations as well, your business users can have better trust in the data and start using that data to start helping with them with their workflows and help drive more informed business decision making from the whole overall business context, not just their functional area, but how it impacts organizations across functions and across domains. So it really helps you align not only your teams, it helps you align your tools and your AI and your data. And it also makes relationships explicit so that as users go into the data, they understand the full context of how data moves from one point to the next, rather than having to build custom logic, custom joins in SQL, for example, or Python even, and custom logic to really bring that data all together into one location. It also improves transparency and explainability by allowing you to embed rules, constraints, and lineage directly into the layer. So you can have all these rules, these data constraints, these cardinalities even within relationships itself, so that the data really understands how it talks to each other without breaking those rules so that you can trust the data in a governed context. So not only is this good for a better data understanding and mobilizing your teams, it's also great from a data governance standpoint in governing your data as well. And then next, it also enables intelligence beyond just your standard Power BI reporting. It gives AI systems structured context to reason and provide insights using generative AI, not only insights, but automating those orchestrated workflows as well. And it really unlocks that true agentic execution by allowing that governed business context, governed business data, and allows those agents and operational agents to start taking that to the next level and using that data to really orchestrate workflows and making sure that you as an organization, you as users, have trust in the data as well. So how do we get started with ontology? The nice thing about ontology is that if you already have a semantic model, getting started with ontology is really simple and really straightforward. Right away, semantic models are the core of ontology. Ontology doesn't necessarily replace semantic models, but takes it to the next level. So if you already have a well-curated semantic model that has well-defined metadata, well-defined relationships, it's a really great starting point to take it to the next level and using that to actually boost how you start your ontology without too much upfront development effort. And Microsoft really supports this because if you actually go into one of your semantic models, you can do this right now if you would like to. If you go to the top right, you'll see this new icon that says generate ontology, which will take all of your predefined definitions in your semantic model, and it'll automatically translate that to your ontology so you can have a better understanding of what that looks like. Awesome. And I'm going to take a quick gap just to see if there's any questions about ontology so far. Awesome. And if there's no questions, I actually want to switch. Mhm.
There's a couple questions in there. Maybe you
Yeah,
already
let's go
got
take a look.
to.
Yeah, and let me actually pull up my Fabric window as well. I actually want to show this in the environment, so I'll answer those questions while I'm in the environment as well, just so we have something a little more tangible we can look at as well. So one question I saw was, does ontology require return actual business data or just ontology objects? So ontology actually returns the data elements. So the nice thing about that is you use the data agent. It's going to be a standard data agent, but instead of now the data agent pointing at those separate semantic models, it's going to use the ontology as the data source. So since it has ontology as the data source, and ontology is connected to those underlying semantic models, you can go ahead and pull that information with the context of your business, ensuring that, hey, it's going to go ahead and handle all those complex joins without worrying about data duplication or breaking data validity or governance rules as well. And I see a question says, how can ontology help with imperfect source data? I think ontology it's not going to fix broken data. Ontology doesn't necessarily change the way we change our modern data platform, where we start trying to ingest data into one layer and just modeling, cleaning that data into those dimensional layers. I think ontology is an extension of that. It's not going to replace it. So the better your source data is, the better you model your data, the better ontology becomes. Instances where you might not really model the ontology data is going to be really that real-time data where data is coming in real time. And you might not want to model that. You might want to ingest that in real time as it comes. And I saw Jade has a question. Is this similar to social networking? Yes, this is exactly, I would say that's like the perfect relationship to what it is. Ontology is essentially social networking, but now applied to your whole enterprise. So similar to how you have your social networks where you have people as nodes or entities and relationships between one another, instead of people being the entities, it's going to be objects within your organization or objects within your business. Yeah, great question. Great questions. Awesome. And let me know if you can see my screen.
Yep.
Awesome. Perfect. All right. So now we're in a Fabric environment. Let's say we want to get into ontology. What's the best way to actually go about it? Like I recommended earlier, the fastest way to get into ontology and really get this stood up is to actually go into one of your semantic models. So in this environment, I have a sales semantic model that has a sales fact, and it has some dimensions that allow me to slice and dice my transactions. Some of my dimensions are my location, my customers, my employees, as well as my items. If I drop this drop down right here in the top right, this might be hidden for you. You can actually hit generate ontology right here. And I'm just going to go ahead and give it a name. And ontology is a full low code experience. So I'll name this my sale ontology. So nice thing about this is that if you're not a pro developer or you're just still making your way, so you're still mostly a report developer, you don't need to know any advanced SQL, no advanced Python. You can do this directly yourself within the Fabric interface. We'll give this a few seconds. So once you do that, the ontology is going to go ahead and scan your semantic model, and it's automatically going to translate that into the ontology itself. And as you notice, there is this blinking black bar going down the left side of my screen. That is I like to say that's a feature, not a bug. And that's a feature of a preview product. So right away, well, it's going to go ahead and generate that ontology. And we can actually start by selecting an entity. So if I select my fact sales, for example, it's going to load that automatic ontology. So based on that relationship that have been predefined in my semantic model, I'll see the fact sales is going to be that entity at the bottom. And if I look at the top on the right side, the window, you'll see all the fields within my fact sales. And these are really going to be the properties of my entity. So the fact sales is my primary entity. It's going to be my transactions. And a good thing to do is actually to start renaming a lot of your entities. So by default, as you take in the semantic model, it's going to go ahead and copy over your table names. But as you use agents and AI into this, it's going to start looking into what these entity names, and it's going to start making inferences on these entity names as well. So I can call this sales transactions, for example. Transactions. It does not like space. And the key is going to be how it relates to another. So how it connects to other entities is going to be primarily through the key. So this is the fact table, but I do have a sales key on here just to say, hey, that's going to be my sales ID. I can go ahead and connect it here. And using this is how it's going to map to your other transactional tables or other entities or other domains within your data. So right now, if I scroll down to properties, it'll show all of my fields and attributes within my table. It'll also show that key, which I've identified as that sales key, which is going to be that unique identifier. Where this gets a little interesting is if I actually go to bindings, it's going to see that the source table is actually coming from my fact sales, which is coming from this lakehouse. However, let's say I was getting sales from multiple sources of information, not only my sales table, maybe I was getting real-time sales from online ordering. I can actually add data to this entity and it can start housing multiple instances. In this case, I don't have a real-time data source here, but I can actually go ahead and grab one of my other data sources and bind this entity to multiple data sources from here as well. So this is where ontology starts allowing you to be more cross-functional, cross-domain as you start bringing this in as well. Going back to my entity types, I'll go ahead and grab a smaller entity because I actually want to show you this graph. But if I actually go into this employee dimension, let's actually go to the customer. It's going to show that the customer dimension, this customer entity, it says fact sales has dimension customer, but we can actually change the name of this as that a sales has a customer. So just starting to define that, starting to add these names, and starting to define these relationship types. And all of this is considered metadata. So as you're starting to feed this into agents or AI does look into this metadata and it helps to get a better understanding of your organization as well. So these are going to be the core components of your ontology as you're working through it as well. And for source data, you can select your workspaces. So in here, I know this feeds off a lake house. And so it's going to go ahead and show that source data of where is that customer data coming from. In this case, my dimension customer. And here you can start defining your relationships further. So how does this tie back to all of these entities and sources as well?
Can you only use, like Lakehouse within Fabric or for the ontology, or can you use like Azure Databricks?
Mm-hmm.
You can.
Right now, based on the documentation, it's primarily Lakehouse and event streams and semantic models. Those are your primary three sources. However, as it's still in preview, so the expectation is that they're going to add additional data sources as well. As the final goal of ontology is to have it on top of all data in OneLake. So at its core, the data needs to be in OneLake. So if you're using Databricks, it would depend if you have that replicated into OneLake or not. So if you're mirroring that into, it has to be in OneLake.
But how does ontology compare to other non-Microsoft tools like Atlan?
Yeah, that's a great question. I think I haven't used Atlan myself. However, I would say in terms of ontology, it's a little, you'll notice like I'll actually click on this entity type overview.
Yeah.
This is gonna take a while to spin up, but truthfully, it's a little clunky at the moment. I think it is because it is in preview, it's a little clunky. However, the vision for it, I think it's a really good vision, and we'll have to wait it out to see how it is in practice. So I think right now it's too early to say how it is in terms of performance. I recommend you apply it to a few data sources just to see how it works out. But in every demo I've seen, and of course in the demo, it's always going to look and work perfectly. But from the demos I've seen and just how it works at the overall arching idea of what ontology is supposed to do, I think it's a great way to really orchestrate AI and workflows. So it's really meant to bridge the data from your multiple functional areas and allow your business to actually get into the data and turn it into information a lot better. So final answer, I know I blurbed a lot, but the final answer is I think it's too early to tell at this point.
Okay, thank you.
Yeah. And this did pop up. So right away, you'll see a relationship graph. This is where I mentioned it still is in preview. And generally with the relationship graph, this is where you'll see how it relates to all of those nodes. So right now I have my customer. However, I can start adding I can start adding other attributes to the network, such as how's it tie back to the city, how's it tie back to the employee, and start adding other networks into here as well. I hit run query, you're going to see that it is a little clunky as it doesn't return anything. However, I believe this one, as it's built out of the box with the semantic model, it does need more tuning. So while this semantic model was relationships were set up properly, this ontology does need more tuning before it gets to that final network state where you saw earlier in the example, or that's the social networking example as well. It does need some tweaking to really get there. Yeah, but great questions. Any other questions from the group?
I think someone has,
Yeah,
Nick has
yeah.
something.
So can ontology extend all the way to reports or business files? As of now, it can only read the data that's in OneLake. So reports, yes, because it can expand to the semantic model. Where it gets a little bit tricky is that if you're using, it depends how your reports are built as well. So it can see measures and calculated columns as well. So it can understand that context, but it's not going to look into the reports itself. So if you have certain structures of how you like your reports, it's not going to understand that. It's only going to understand the underlying data and the relationships and the roles you define in it. In terms of files, it would depend if it lands in OneLake. So let's say you have those files ingested and landed into the lakehouse, then yes, the ontology can reach into those and use those as a layer in the ontology. Yeah, but all great questions. Any other questions from the group?
Doesn't look like it.
Awesome. Awesome. If there's no other questions, that I think the time worked out. It's pretty much wrapped up my presentation today. So I hope you learned something new. I know ontology is a lot to take in, and it's the nice thing about the fun and exciting thing, for better or for worse, about ontology is that since it is in preview and since it's only 2-3 months old, it's ever changing. I know every time I look at the documentation, it changes a little bit, but it's something that I'm really excited about and excited to see the direction that Microsoft takes with it. I think it's going to be a game changer in terms of taking AI to the next level. Right now, I would say AI only knows what it knows, and this really allows it to start making inferences and informed decisions as well as thoughts rather than just relying on what's in the data. And before I close out, just want to say thank you. Thank you for hosting me to the user group, and thanks for allowing me to spend an hour of your time with you. And if you want, my LinkedIn is there, so feel free to connect with me. Always happy to chat. And for those who are going to Fabric Conference in Atlanta next month, I will be there. So happy to meet up or connect in person as well.
Thank you, Samson.
Great. Thank you, Samson. Yes. That is a lot.
It is a lot to take in. I check the documentation, I think, every week since it's been announced just to see what's new. And it changes a lot. I think from the keynote where they announced it to now, even the features itself have changed.
Yeah.
So,
I
but I think it's something you want to definitely keep your eye out. And I saw there's a hand raised in the chat. Was there another question?
Yeah, this is Nick. Thank you very much for the presentation. So this allows the business to define their semantic model, and then you can combine what you call a business concept to these data elements. Is there anything in place for we'll use the term like tracking context? So for example, someone can we'll use my favorite example when I used to work at General Motors, vehicle. So a vehicle could be, something that's got an engine and everything and that's sold to a customer, or a vehicle could be something that's just a chassis sitting on, a assembly line somewhere, or it's something that's on a truck. And so it sort of has to know, well, when you ask about, I want vehicle data, which vehicle are you talking about? And that's sort of more what I like. Oh, well, if you're in, finance and you're answering this question, then this is what vehicle is. But if you're in manufacturing and you're trying to answer this question, then this is what vehicle is.
Mhm.
Is there anything in this that sort of tracks that kind of ambiguity between like these solid, this is the defined, definition of vehicle?
Yeah, and that's a really good that's a really good example I think that you pulled up. A lot better than my example with the restaurant, but yes, to your point, ontology aims to fix that. So that's like the primary gap ontology aims to solve. So within your example of a vehicle, there will be multiple relationships going at that vehicle. There's going to be a vehicle relationship to manufacturing side. There's going to be to the finance side from terms of the accounting perspective. There's also going to be a vehicle from the sales side, for example, as well. So all of those components are attributes of the vehicle. And within the ontology, you can define how that relates to each entity. So some side relationship we mentioned earlier, on top of saying, okay, let's say one manufacturer can produce many vehicles, you can also define the rules of what vehicles it can produce, as well as any constraints and rules as well. So it does allow for that fine-grained definitions, as well as those rules around it as well that allow you to reduce that ambiguity. But to your point, at the end, there is going to be a little bit of prompt engineering if you're using this in AI context. So
Okay.
depending who asked the question, they should define as a, hey, like how much do vehicles cost to manufacture this month, for example. And it's going to pull from manufacturing, it's going to pull from accounting as well. Does that answer your question a little bit?
It does.
Okay.
I'm chuckling just because how much does this vehicle cost is one of the primary questions that
And then
no one knows
yeah,
the answer to.
and it hits every functional area. So that's a really good one. It's like there's just too many different expense accounts it hits probably from an accounting side, and from a manufacturing side, it's another rabbit hole. Yeah, so this aims to solve that. Seeing it in practice though, too early to tell. So very curious to see how it gets refined. Yeah, any other questions from the group? Awesome. If there are no questions, thank you so much for your time. I'll hand it back.
Yeah, thank you very much.
I'll hand it back to the team with their
Great.
announcements.